So there are basically two types of bonds that we're going to focus heavily on over these chapters. The first one is an ionic bond, and these are atoms that gain or lose electrons. Okay, and it's going to have to occur with at least two atoms, so I'll make sure you recognize that. And they're basically held together by opposite charges. A key thing to remember here is that they are always between a metal and a nonmetal. Second type of bond is a covalent bond. In these type of bonds, they share electrons. And these bonds tend to be stronger because of the fact that they are sharing electrons. It's kind of like locking hands together. It's very difficult to pull hands apart when they're held together, but ionic bonds, on the other hand, are held together by opposite charges. It's kind of like static electricity holding socks together that were run through the dryer. Easily separate socks, whereas trying to pull someone's hands apart, much tougher. Covalent bonds are always between two nonmetals. Okay, so it's important that you're able to recognize where those are on the periodic table. So if we look on the periodic table, we've got our metals on the left-hand side of this staircase right here. And we've got our nonmetals on the right-hand side. So if I've got a bond between some metal and some nonmetal, the type of bond that we would get out of that is an ionic bond. If I take two nonmetals and I form bonds with those, I'm going to get a covalent bond. So a little bit more with ionic bonds here, and we'll focus heavily on those over the next few days. But ionic bonds, again, are between a metal and a nonmetal. We're going to show an electron being moved from one to another, and they're being held together by opposite charges. So there is nothing physically holding them together other than the fact that we know in physics that two opposite charges, plus and minus, will be attracted to each other. So if I wanted to, I could separate these. I would just probably have to get the electrons moved back, but there's nothing physically holding them together. Questions that you should think about when you're studying ionic bonds. Do metals want to gain or lose electrons? So if you think about your metals, those are the left-hand side of the periodic table. They have anywhere between 1 and 3 valence electrons. So I'm just going to list a couple of these here. So we've got sodium with 1, magnesium with 2, aluminum with 3. And they all kind of fall into this pattern where they have up to 3 valence electrons. So you have to ask yourself, is it easier to gain electrons and get them up to 8, or is it easier to lose these electrons and get them down to a lower number? The answer to that one is that it's easier for them to lose electrons. So metals will tend to lose electrons. If you think about nonmetals have 5 or more valence. Oxygen would have 5 dots around it. Oxygen would have 6. Fluorine is going to have 7 dots. And of course, our noble gases will have 8. So if you ask yourself the same question, do they want to gain or lose? It's much easier for them to gain electrons than it is for them to lose these electrons. So knowing this, are metals cations or anions? Remember, cats are positive. They'll give you a positive charge, and anions are negative. So think onions make you cry. So for metals, because they're going to be losing electrons, they are cations. They have that positive charge. Nonmetals, on the other hand, are gaining electrons, so they are anions. Okay, covalent bonds, again, these are bonds between 2 or more nonmetals, and they are sharing electrons. So this is showing you hydrogen has 1, carbon has 4. And if we start combining these electrons right here, hydrogen is satisfied with 2 electrons, so it meets its role. And carbon, if you count up each one of these carbon atoms, it would add up to 8. So it's meeting the octet role again. And again, this is held together by physical means. They are sharing electrons. So it's very difficult to break that. One important thing to note here is that the charge is remaining neutral. We're not gaining or losing electrons in the end. All we're doing is kind of combining them into a set area. So hydrogen isn't truly losing, it's not truly gaining. So it overall has a neutral charge. If we think about our ionic bonds, these guys are becoming charged. But if you think about their charges, in the end, if I take sodium and chlorine, so sodium's going to end up with a +1 charge. Chlorine's going to end up with a -1 when it gains its electrons. So if you look at this, here's our bond. They're held together by opposite charges. And the +1 and -1, if you look at that, they cancel out. So we're keeping to the idea of neutral, but we are able to form ions in ionic bonds. That's where it gets the name. Last thing to kind of introduce us here is the number of binding sites. So if you think of carbon, it has 4 valence electrons. Nitrogen has 5. Oxygen has 6. Hydrogen has 1. Chlorine has 7. So if you look at each one of these elements here, so that means it can gain 4 bonds. It can have a total of 4 bonds in order to fill these up. Doesn't have to, but we can get up to 4 bonds. Nitrogen has 3 binding sites, so it needs 3 more spots to be filled for it to get up to 8. Oxygen has 2 binding sites, and hydrogen has 1. So that means that we can have up to 4, up to 3, up to 2, and hydrogen will only form 1 bond. It'll never form more than that. Chlorine, it only has 1 binding site also. So it will only form 1 bond also. So this is the lesson on the introduction for ionic and covalent bonds. So go ahead and work on the worksheet practicing this and become very comfortable with this material because this is really the core of everything you learn in chemistry.